After acquiring a deep mathematical sense of what beta 1 and beta 0 mean, let's go back to the actual curves and explore what we learned last time and better visualize their behavior. First, let's plot our old probability equation, and then remembering that the odds function provides a more sensible behavior, especially with respect to beta 1 and beta 0. We'll plot that curve too. And of course, to be very thorough, let's plot the log of odds function as well. As expected, each curve always moves in the same direction as the other two. For example, since beta 1 is a positive number here, namely 1, and all three curves are increasing functions of x. If a negative number was assigned to beta 1, all three curves would become decreasing functions of x. As for beta 0, as was predicted by the equations in the previous video, the intercept of the log of odds function with the y-axis equals beta 0, or in this case 0, and the intercept of the odds function with the y-axis equals e to the beta 0, in this case e to the 0 or 1. Remember that by a unit increase in x, the value of odds would be multiplied by e to the beta 1, and the value of log of odds would be increased by beta 1. Now, it's time to explore what all that means visually. If what we found out mathematically was true, the odds curve has to pass through the points 0 and e to the beta 0, and 1 and e to the beta 0 times e to the beta 1 because of the unit increase in x. The plot verifies this notion. As for the log of odds, we predict that the curve has to pass through the set of points 0 and beta 0, and 1 and beta 0 plus beta 1, again because of the unit increase in x. And once again, the plot proves this point. Now we can generalize all our findings and let beta 1 change. We observe that for positive beta 1s, all three curves go up. The larger the beta 1, the faster the odd curve races to infinity, the more steep the probability curve becomes, and the slope of the log line increases as it is always equal to beta 1. Permitting beta 0 to change also helps prove a point. When the probability at x equals 0 is less than 50%, this results in an odds of less than 1, as you can see here, and which results in a negative log value here at x equals 0, which is actually equal to beta 0, because beta 0 was the intercept of the log of odds with the y value. Equivalently, a positive beta 0, let's say, a positive beta 0 means a positive log value at x equals 0, which means an odds value more than 1, which means a probability of more than 50% at x equals 0. So by looking at the probability value at x equals 0, we can have a sense of what beta 0 is going to be. If probability is more than 50%, then the odds value would be more than 1, which means that the log of odds would be a positive number, and log of odds at x equals 0 is actually beta 0.